In this lecture, we are going to look at the oxidation of olefins. The olefins are also called the alkenes. They are unsaturated hydrocarbons. And this will be the lecture 2 of our oxidation lecture series. So let us dive right into what the lecture is all about. Now, at the end of the lecture, what are you expected to know? Now, the first thing that you're expected to know is to determine the various methods of oxidations of alkenes. And the second thing is to determine the various reagents for the oxidations of olefin. If you know these two, then the purpose of this lecture is served. So, now what are the alkenes? That will actually serve as our first question here. What are the alkenes? Now, like I said earlier, the alkenes are unsaturated hydrocarbons. Now, when you say an hydrocarbon is unsaturated, it means that it has a double bond. We have them having the general form of this, where this double bond is the site of reactivities of all alkenes. So this is the site of reactivity. Now, what is the general formula of the alkenes? The alkenes, they have the general formula of CnH2n. Now, all alkenes usually start, or let's say the alkene homologous series start from when n is equal to 2. N is equals to 1 is methylene, but in most cases, methylene is always studied as a separate entity of its own and not among the homologous series of the alkenes. Reason being that you need at least 2 carbons in order for unsaturation to take place. So when n is equals to 2, you have C2H2 times n is 2, and this will give us C2H4. And this is the alkene that is called ethene. And then the process continues for n is equals to 3. This gives us C3H2 times 3, and this will give us C3H2 times 3 is 6, and then we call this propene. And then the process continues like that. Here you have butene, pentene, hexene, heptene, octene, nonene, and decene, which has 10 carbons. Now, talking about the oxidations of olefin. When alkenes or the olefins are oxidized, so we have olefin plus oxidizing agent. Let me use this to indicate the oxidizing agent. Now, what are we expected to form as the product of this reaction? Now, this reaction will give us either a carbonyl functional group or it will give us a carboxylic acid group. Now, this carbonyl can either be an aldehyde or it can be a ketone. So in essence, what we are trying to say is that whenever the olefins, which are the alkenes, like I said, that the other name for the alkene is the olefin. Whenever these olefins or the alkenes are oxidized, the product is usually a carbonyl group or a carboxylic acid. The carbonyl group can either be an aldehyde or a ketone, depending on the nature of the oxidizing agent used and on the nature of the olefin. Now, the next thing that we are going to look at is the method of oxidation of alkene. Now, oxidation are particularly important, reason being that most functional groups contain oxygen. Alkene oxidations are some of the best methods for introducing oxygen into a double bond. Now, most alkenes, like we said, all alkenes usually have a double bond. So, oxidation of this alkene is one method of actually introducing an oxygen into a double bond, to form a carbon oxygen bond, something like this, to form a carbon oxygen bond, which can either be in the form of a carbonyl group or a carboxylic acid. Now, the method of oxidation of alkene ranges from the following. Now, the first one we are going to look at is the oxidation of polycyclic olefins. Oxidation of polycyclic olefin. Now, we are going to look in details of what the polycyclic olefins are and then their product of reaction in our next lecture. Now, another method is dihydroxylation. Now, as the name implies, di means two. Hydroxylation means two hydroxy group added to the alkene double bond. Dihydroxylation reaction. That is another method of introducing or of oxidation of alkene. Now, the next method we are going to look at is epoxidation. That means the formation of epoxide, which is a three-membered ring compound that has oxygen in it, and they are also called the oxirings. Now, we are going to look at them in the next episode. And then finally, the last method of introduction of an oxygen or of oxidation of alkene is oxidative cleavage, also called ozonolysis. Oxidative cleavage, also called, which can be achieved. It must not always be ozonolysis. It can be achieved by the process of ozonolysis and by using strong oxidizing agents like KMNO4 etc. So these are the method of introducing an oxygen into the alkene double bond, or we can say that these are the method of oxidation of alkenes. Now, having known this, the next thing that we are going to look at are some of the oxidizing reagents. Now, the oxidizing reagents that are used for oxidation of alkenes are as follows. Now, one of the oxidizing agents that we are going to look at is chromium trioxide. Chromium trioxide. Of course, most of these oxidizing agents, they don't actually carry out this process of oxidation alone, as they usually join with other agents to carry out the function of oxidation. So when you say chromium trioxide, it may be actually dissolved in some sort of solvent. Are you getting it? We are going to look at them in detail later. So chromium trioxide, which can be written as CrO3. This is the formula of chromium trioxide. Now, another oxidizing agent that we are going to look at is osmium tetroxide. Osmium tetroxide, which can be written as OSO4. Now, the other oxidizing agent is potassium permanganate. Potassium permanganate is KNNO4. Or you can call it potassium tetraoxo or whatever. Then the next one is iodine silver acetate for oxidation of alkene. And then another oxidizing agent that we are going to look at is selenium dioxide, which is CEO2. And finally, we have chromine chloride, which is something like this. Chromine chloride. Are you getting it? Something like this. So all these are oxidizing reagents that are used to oxidize olefins to give us carbonyl compounds and carboxylic acid. Of course, carboxylic acid is one of the carbonyl compounds, but when I make carbonyl compound here, know that I'm talking about the aldehyde and then the ketones. So you may be asked, what is the product of oxidation of carboxylic acid? What would you say of alkenes rather? What would you say? It could either give an aldehyde or a ketone, or let's say a carboxylic acid, depending on the nature of the oxidizing agents that was used. Now, having looked at all these oxidizing agents, Now we are going to look at how each of these actually oxidize olefins or alkanes and the product that is required, or the product that is actually gotten at the end of the oxidation process. Now let us look at one of the oxidizing agents that is listed here, and that is chromium trioxide. Now we've been looking at chromium trioxide since when we talked about how chromium trioxide oxidizes the methyl group of aromatic hydrocarbons to give us carboxylic acid. If you can remember, we did something like this in the other lecture, which is lecture 1. Please, if you have not seen it, you should try and go through it, where we said if this is toluene, which is also called methylbenzene, and then you oxidize this with chromium trioxide and H2SO4. This will be oxidized to give us a benzoic acid, right? We talked about something like this. Now this chromium trioxide also is used for oxidizing primary alcohols, secondary alcohols, and other varieties of functional group, including alkane, when it is actually reacted or mixed with different oxidizers or different other agents. It does not work alone. Like we said, that the CNS does not discharge as a complete unit. The ANS does not discharge as a complete unit. The chromium trioxide does not work alone. It actually requires some solvents that will aid in the oxidation process. So let us talk about the chromium trioxide. What is it? It has the general formula, or it has the formula of CrO3. Now, chromium trioxide is a strong oxidizing agent that is insoluble. Chromium trioxide is insoluble in most organic solvents. Insoluble in most organic solvents. But it is soluble in some solvents such as pyridine and tertiary butyl alcohol, such as pyridine and tertiary butyl alcohol. Now, chromium trioxide has various applications in various oxidation process, but like I said, that it doesn't function independently. It actually reacts with other reagents, or let's say other chemicals, to form different oxidizing reagents. Now, what are some of these reagents that chromium trioxide reacts with? For instance, in Collins reagent, you have chromium trioxide. So we can say the Collins reagent comprises of chromium trioxide plus pyridine. So we have CrO3 plus pyridine plus dichloromethane. Dichloromethane is something like this, CH2Cl2. Now this CH2Cl2 plus chromium trioxide plus pyrimidine, plus pyridine, is what forms the Collins reagent. Now, what is the function of the Collins reagent? What is it used for? Collins reagent is used for oxidizing primary alcohol to aldehyde. It is used for oxidizing primary alcohols to aldehyde. Now, from what you just noticed now, that it is used to oxidize primary alcohol to aldehyde, can we actually draw out a premise that Collins reagent is a mild oxidizing agent? Because normally, if it is a very harsh oxidizing agent, it will oxidize primary alcohol to aldehyde, and then from aldehyde to be oxidized to carboxylic acid. That means the process will not stop at just the aldehyde. But because Collins reagent is a mild oxidizing agent, it will oxidize it and end at aldehyde. And it's a combination of chromium trichloride, or we can call it chromic acid, in pyridine plus dichloromethane. Now, the next one, or the next reagent that you can actually find chromium trichloride, or trioxide rather, is the Jones reagent. Now, the Jones reagent comprises of the following. It comprises of chromium trioxide, as the name implies, plus aqueous sulfuric acid. That means sulfuric acid in water, right? Aqueous H2SO4 plus acetone. Now, what is the functions of the Jones reagent? Now, the Jones reagent actually oxidizes primary alcohol to aldehyde and oxidizes secondary alcohol, which you can call 2-degree alcohols, to ketones. Right? It oxidizes them to ketone. Now the next one is the Sarriette reagent. Sarriette reagent is chromium trioxide and pyridine. Chromium trioxide and pyridine. So we have it as this: chromium trioxide plus pyridine. Now what is its function? It oxidizes alcohols to aldehyde and ketone respectively. So we say primary alcohol, or we can call them the 1-degree alcohol, will be oxidized to aldehyde, and then of course 2-degree alcohols, which are secondary alcohols, will be oxidized to what? Say secondary alcohols are usually oxidized to ketones, so this will be oxidized to ketones. Now, another thing that you must know is that chromium trioxide is not, you won't go to the market. For instance, you are a pharmacist, you want to do a formulation, or you are a chemist, you want to actually carry out a particular synthesis, and you need chromium trioxide. You will not see chromium trioxide as chromium trioxide, but you see the salt of it. Now the salt is in the form of sodium dichromate. That means you have it as sodium dichromate, or some persons call it sodium heptaoxodichromate. Then you calculate the oxidation stage. The oxidation stage is supposed to be somewhere around 6, right? Let's calculate sodium. This chromium 07. Now sodium is 1. 1 times 2. Calculation of oxidation stage should not be a problem at this level. 1 times 2 is 2, plus chromium is 2, so we have 2CrO, plus oxygen is minus 2 times 7. Everything is supposed to be 0. So this is 2 plus 2CrO minus 14 is equals to 0. 2 minus 14 will give us 2 minus 14 will give us minus 12 is equals to 0. Take this 12 to this side. So 2CrO is equals to 12. Divide both sides by 2. Divide both sides by 2. When this cancel this cancel this, CrO is equals to plus 6. So it is sodium heptaoxodichromate 6 as the form in which chromium trioxide is available in the market commercially. So if you want to get chromium trioxide, you don't go to the market and say you want to get chromium trioxide, but you get the salt of it, which is formed from when you react. I don't want to go deep into the chemistry of it anyway, but when you react chromium trioxide with H2SO4, 2H2SO4, it will form the chromic acid, which is H2CrO2O7, something like this. 2CrO2 plus 2H2O is going to form this. Now when this is an acid, when it reacts with sodium hydroxide as a base, it's going to form this sodium dichromate, which is O7. But that should not be an issue to you at this level. So that is everything you need to know about the reagents that are used for the oxidation of alkane. Now, in our next lecture, we are going to look at how each of these reagents actually oxidizes alkane, which is oxidation of polycyclic olefin number 2. Because we said initially here that the forms in which alkanes are oxidized are 1. Oxidation of polycyclic olefin, dihydroxylation reaction, epoxidation reactions, and oxirins, and then we have oxidative cleavage, which can be achieved by the process of ozonolysis. So if you are asked what are some of the reagents that can be used to oxidize alkene, you say osmium tetraoxide, chromium trioxide, potassium permanganate, iodine silver acetate, selenium oxide, chromium chloride. Each of these oxidizing reagents have different products that they will give upon oxidations with alkane. Thank you very much for your time. Make sure that you see the next episode or the next lecture, as I'll be talking about the first method of oxidations of alkane, which is the oxidations of the polycyclic olefins. Bye bye. Catch you in the next lecture.